So on the shark bite, which ones do we want to see, go over, had questions about the most? Okay. So 2, 3, and 4 can be done on Desmos, so we're going to do those anyway, and then I saw 1 and 5, so we'll do them all. 1 and 5 can't be done on Desmos, so these would be ones you would have to know. So the range is our X's or Y's? Y's. So this is kind of like the one we did before that I was asking about the domain of these same numbers. So we're looking for the Y values here. They cannot repeat, and then we need to list them least to greatest. So it would be -5, -3, -2, and that's it. You would not put the repeats. Questions on that one? For number 2, you could have solved this in Desmos. So if I put this all in, you'll see that nothing happens. As much as you zoom out, they're not there. So you would have to do these separately, put in one side of the equation and then the other. And you may have saw what just happened, that they overlap each other. Because they're overlapping everywhere, and we're going to talk more about this today, this would be infinitely many. Number 3, if you were to put that in as is, as long as you know what you're looking for, you could find the equation for this. You're given your y-intercept, you can count your slope to this point. Our slope would be up 1 to the right 3. So the equation of this line should be y equals 1 over 3x minus 1. And if they overlap, that is the case. So that would be your answer for number 3. Questions on those two so far? With 4, you can also put that in all at once. This over. I have the thing right in front of me. So it's going to give you a straight line. It won't tell you the number, but if you zoom in, you can see what number that is, because if you put these in separately, it would make curves. But x equals -2 is your answer for that. If you were doing it algebraically, you would cross multiply, distribute, get your x's on one side, constants on the other, and then solve. So x equals -2 for number 4. Then our domain for number 5, something you'll need to know, is that this is going from left to right, furthest point to the left, furthest point to the right. Is this discrete or continuous? Which one? The discrete would be random points. This one's continuous because I can draw this line without picking up content. So because it's continuous, it needs to be written a certain way. Starting at the furthest point to the left, -3, and ending at the furthest point to the right. Questions on any of those? Look at your calendar really quickly. Notice that there are Khan Academy quizzes due basically every Friday except for the last Friday in March. And that we are going to quiz and test this before spring break. So this might go a little fast. But also this will be the last thing that goes in marking period 3. So we're going to test on the 23rd. I'm going to get it back to you as soon as possible so you can retake, if necessary, do the retake work and retake on the 27th. And then you'll have to come before or after school if you don't get it done that day. Because last day to turn in missing work / retakes is the 30th. Because the quarter ends on the 31st. So keep those things in mind. What questions do we have on that?
What is
Literally the week after that. So April 2nd through the 7th or something. And then you guys get 1 extra day because it's the teacher work day. So the 3rd through the 7th, and then the 10th. No, I haven't. It doesn't bother me, so I just let it be. Other questions? Okay. So we're going to start these notes before lunch and then we'll finish them after. Pass up your answer sheets, your Shark Write answer sheets. While you're doing that, I'm going to briefly talk about what this unit is. So we've talked about solving equations, graphing them, writing them, word problems, all those different things separately. Now we're going to be talking about a system, which is more than one, and talking about different ways to find the solutions to those systems. So as you're passing those up, I want you to write these things down. Draw the graphs as best as possible. Doesn't have to be perfect. as you're finishing writing, I'm just going to talk through what you're writing. So a system of equations is two or more equations with the same variables. When we are looking for the solution to the system, graphically, it's the point xy where the two lines intersect. Algebraically, it's the point xy that makes both equations true, and we'll talk about what that means in a bit. And then there are three types of solutions, just like before when we were solving equations. One solution, where they intersect. No solutions, they're parallel lines, they have the same slope, so they don't intersect at all. Infinitely many solutions, they are the exact same line, so they intersect everywhere. And then to figure this out, to solve it, if the equations are not in slope-intercept form, we would change that first, and then graph them, and then find the solution. Anyone still writing? Couple things before we start. One, if you need or want a ruler to make your lines really straight, I have some in the colorful trays. If you would like to do your graphs in two separate colors, because I'm going to be doing that, I also have colored pencils in the colorful trays. We have time to do one. So let's do number one. Where would we start graphing this at? The first one. We could say it out loud. Nature. -8, so plot that. And then what's our slope? So look for the number in front of x. What's our slope? 1. You're going to go up 1, right 1 as many times as possible. Fill up your graph. And then down 1, left 1 as many times as possible. Fill up your graph. Draw a line through all of your points. And make sure your line has arrows. Then where would the second one start? Matthew. Positive 1. And our slope is negative. What directions could we go to get a negative slope? Up and left, down and right. So either way, you have to go both. Go up to left 1 as many times as possible. And down to right 1 as many times as possible. And we'll come back and finish this. No, I was going to get cold. I always get cold. Where do those two lines intersect? Matthew, close your laptop. Exam, close your laptop. Nature. Three. So after you find the solution, that's it. That's all you have to do. questions on that one? We're going to skip to the back. I'm going to do number 4. So 4 has one where you have to solve it. So whether you solve that one and then graph both of them, graph the one that's given and then solve and graph, that order doesn't really matter, even though we just wrote the steps. So I'm going to go ahead and rewrite this down here so I have space. How would we solve this? On both sides, rearrange the x and the y. I'm sorry, the x and the constant is what I'm making. And then what? Really? So when we do that, what would our new equation become? Paper. Before we graph these, what do you notice about the equations? Really? They're the same. So that means this is going to be what type of solution? Measure. You put IMS, you can spell it out, you put the symbol, either or, doesn't matter. Any of those doesn't matter. So when we graph this, we just need to graph the line at least once, and I'll show you how you can show the second one. So start at positive 2, go up 1, left 2, as many times as possible. Down 1, right 2, as many times as possible. And then you could do a couple different things. Highlight over the line you drew to show that there was a second one. Draw in another line in a different color right next to it. Or you can just extend your line like it has double arrows. Any of those options work. I did meant to mention this. You can be using your calculator, and I'm going to show you how to check it in your calculator. But when we go to quiz and test, this objective will be non-calculator. So you may want to get in the habit of practicing without it. Questions on that one? Let's do another, and then we'll go over any you guys want to see, have questions on. Let's do 6. So 1 is solved for us. If you want to graph that first, you can. If you want to solve the second one first, you can. Doesn't matter. I'm going to graph it. Every time. Okay. Trying to not make it laugh. What's the slope of that first one? Matthew? 1. So up 1, right 1. Down 1, left 1. If we were to solve the other one, we would subtract x on both sides. Divide everything by -1. So before we graph this, what type of solution would these have? Nature? type of solution because the slopes are the same. These are going to be parallel lines. So if I graph this, I'd start at -2, up 1, red ones. Down 1, left 1. And connections. And I can see that these two lines will never intersect. So the solution is none. Once you finish drawing that and writing the answer, look at the other graphs we skipped over, 2 through 8. Find any you want to see, go over, have questions about. Sure. The 7 is the same, you just have to solve both of these first. So I'm going to solve this second one first. Which one you do first doesn't matter. And then I'm going to go ahead and graph that. So start at -6. Your slope is -2, so up 2, left 1, as many times as possible. And down 2, right 1, as many times as possible. Once you have that work and graph, you can do the other one. So get rid of your x term. And divide everything by -5. So we'd have y equals a positive 3/5x plus 7. Without graphing, if I'm comparing the slopes, I know it's going to have one type of solution. They're not parallel lines. They don't have the same slope, so it can't be none. And they're not the exact same, so it can't be infinitely many. I just have to figure out what that is. So start off at 7, and you can go up 3 to the right 5, down 3 to the left 5, while you're drawing your second line, you'll probably see what your solution point is. If you want to pause, write it down, and then go back and finish your graph, that's fine. You just have to make sure you finish off your graph. What would our solution point be? Positive 5, 4? -5, positive 4.
I'm not sure where I was wrong.
Oh. on to the next page. The one that looks like this. So graphing it is one way to find your solution. This would be like if you graphed it already, you found the solution, you want to double check to make sure, is this the actual solution or did I graph this incorrectly? So this would be how we would do this algebraically. If we were given some equation and like x equals 3, maybe the whole point, how would we know that that's the right answer? How could we check ourselves? Nature? And then solve it, see what that is. So we're going to do the same thing with this point, except we have to put it in both of these, because in order for a solution to work, it has to work for both, otherwise it's not the right solution. So we're going to put both 3 and 2 into this. So 2 equals negative 1/3 times 3 plus 3. Negative 1/3 times 3 would give us what? Negative 1. Does negative 1 plus 3 equal 2? Yes. So that one works. But now we have to try the other one. Put that same point back into the second equation. So 2 equals 2 times 3 minus 4. 2 times 3 gives us, you can say it out loud, 6. Does 6 minus 4 give us 2? Yes. So since this works for both, we can say this is the solution. If it only worked for one or didn't work for either, it would not be the solution. Questions on that before we do another? Let's do 3. Same process, but different format. We don't have to change these. You can if you want. That would be a little time consuming, but you don't have to do that. You can put these in exactly as you see them. So 4 minus 4 times negative 2 equals 12. Negative 4 times negative 2 would give us what? Positive 8. Does 4 plus 8 give us 12? Yes. And then we can check the second one. So 3 times 4 minus 2 times negative 2 equals negative 4. So we have 12 plus 4 equals negative 4. 12 plus 4 gives us what? 16, which is not negative 4. So this one does not work. So this cannot be the solution. Questions on how that works? I want you to do the other two, and then we'll come back and check it together in a couple minutes. What did we get for number 2? No. Does anyone need to see that one? So one of them did not work, or at least one of them did not work. What about number 4? Yes. Did anyone need to see that one? Okay. So if we put these into both, this would be 5 times negative 2 minus 2 times negative 1 So this would give us negative 10 plus 2, and that is negative 8. Then same thing, 3 times negative 2 plus 2 times negative 1 equals negative 8. So this would be negative 6 minus 2, and this does give us negative 8. So since they both work, that would be a yes. We just have a couple more things that we need to go over, and then we'll be done for today. So at the bottom of this, it says state the system of equations and the solution. So we have to find what the equations are and figure out what the solution is. So what would the equation of this line be? Think about your slope, find your y-intercept. What would that equation be? Repeat that. So negative 5.
So the first one like is negative 1/2 x minus 2.
You're doing this one, which is fine.
Oh, sorry. So the other one like was negative 3/2 x minus 12.
So we're going down 3 to the right 2. Our y-intercept is negative 4. And then, as Nature said, the other one is negative 1/2 x minus 2. What's the solution? Where do the two lines cross? Negative 2, negative 1. Okay, we won't do all of these. We'll do one more and then move on. So you guys choose 6, 7, or 8. Anyone? Matthew? Okay. So find the equation of this line. Josephine, did you find this already? So you should probably do more. What was our equation?
y equals 24x times 1.
Up 1 to the right 4. My line is a little crooked, but it should be going over 4. And then the line of the second one. Anyone figure that one out already?
Negative 1/2 x.
And what is our solution?
Negative 4.
So not only should you know how to graph it and find the solution, but you should also know how to write the equations and find the solution as well. Questions on this process? So then, really quickly, this would be a really good way to check yourself while you're doing Khan Academy practice in a little bit. I'm gonna, on this page, show you two different ways you can check yourself. Remember that even though on the quiz and test you will not have your calculator, while you're practicing, you could double check your work. So we're going to do 1 and 2. 2 I'm going to show you in Desmos. 1 I'm going to show you in the calculator. So I'll do 2 first. So for this, you can type it in exactly as is. If you see 2 lines, you may just have to zoom out until you find where they intersect. But that would be a good way to double check, did you graph it correctly? Did you find the correct solution? Questions on how to check it in Desmos? For number 1, I'm going to show you how to do it in your calculator. So you would have to put both of these into your y equals. Once you have them both in your calculator, you can hit graph. If you can't see where they intersect on your window, you may have to change the window size or zoom out. If you can, you might be able to count exactly where it is. My eyes go like this when I try to read this graph. So I'm going to make the calculator find it for me. So I'm going to go into second trace. What do you think we're looking for? Intersect. And then hit enter. Once the cursor's on one of the lines, hit enter. And then the second one's on the second one, enter, and then one more time. And it'll tell you what that intersection is. So use this to double check yourself while you're practicing, but remember that you won't have this ability when you go to take the quiz and test. Questions on calculator or Desmos, how you check yourself? So for the remainder of class, you can be working on practice in the rest of these notes. You can work on Khan Academy, use Desmos, use your calculator. Let me know if you have questions. You guys can work together.